What somebody put for the answer to this yesterday? Quick. If you wish to stay in your seat, one of the biggest tests you're going to pass is when we start, you're going to need to stop talking. So if you want to stay where you're at, you need to learn to make that transition as quickly as possible. Marco, what is the function of a toaster? It eats your Pop-Tarts and waffles? Eat. Gotcha. Yes, sir. What if it's already hardened? So what does your toaster like reject said substance? Anybody else? I like that though. Anybody else want to share? Doesn't have to be perfect. Yes. The toast. Straightforward to the point. Well, I'm impressed. Most of the time, all people put, and if you put this, that's fine, but most of the time what people put is just 2 toast bread. 3 words. That's what they say. And what's interesting about that is I then throw at them, of course I didn't get to in this case, because other people were already on the ball, so I'm like, well, if it's the toast bread, what if you put Pop-Tarts in? What if you put bagels in? What if you put a hot dog bun in, etc.? Hey, Latifah. Okay. The function of a toaster is to toast whatever you put into it. You put bread in, you get toast out. You put squealing little mice in there, you get toasted squealing little mice out. Whatever you put in, it toasts it and spits it out. Now, are you going to put a Pop-Tart in and a dolphin fly out? No, obviously not. Whatever you put into the toaster directly relates to what comes out of the toaster, hence its function. Today, we're going to be talking about mathematical functions. And functions, the whole purpose of them is they're basically just equations. Well, actually, they don't have to be equations. But the whole thing about functions is what goes in directly relates to what comes out. For instance, look at number 9 here. When you have a function is something that you put a number in and you get a number out. Like f of x equals 2x could be a function. Y equals 2x is a function. If you put 2 into that function, you're going to get 4 out. You put 3 into that function, you're going to get 6 out. You put negative 7 into that function, you're going to get negative 14 out, etc. Where something ceases to be a function, if you can put in one number and get multiple numbers back, then it's not a function. Because functions are said to be one-to-one, where for every one thing you put out, it directly determines one thing you get back. So let's look at like number 9. Some functions, they won't even give you an equation. They'll just say, here's some coordinates on the coordinate plane. Could they represent a function? And the only thing that you have to worry about whether something can or cannot be a function is if you put in something but get different things back. In other words, if you have a repeating x value with different y values, that's impossible. That's like I put in bread and got back toast. I put in bread and got back Pop-Tarts. I put in bread and got back toasted little rats. That's impossible. So number 9, determine whether each relation, which is just a series of points, is a function. Number 9 would be no, because you have a repeating x value with different y values. And that is the only requirement. If you do not have repeating x values, then it's a function. Number 1, are any of my x values repeating? Then it's a function. Doesn't even matter what the y values are. What about number 3? Not a function. My 3 gave me 2 different possibilities, errant, and my 4 gave me 2 possibilities, so double errant. What about number 5? Yeah, there's no repeating x values. We're good as gold. About number 7? Yes, it is. There's no repeating x values, and that is the only thing that matters. Now, it would be stupid and redundant, but let's say they put like 1, 1, or 1, 2, and then 1, 2 again. Well, technically, if it said the same thing twice, that would be kind of redundant, but technically it wouldn't be wrong. It would be like you put in bread, got back toast, and then you put in bread again and got back toast. So as long as the y value is the same, I guess technically you could have a repeating x value. But you probably are never going to see that, but just in case, that wouldn't be a problem. Questions about what you're going to be asked to do on these problems? Okay. Determine whether each relation is a function. Oh, we just did that. What the heck happened? Okay. Evaluate each function at the given values of the independent variable and simplify. All you have to do, they're giving you, these are functions. All of these are functions. The only letter you really, this is called function notation, okay? And it's not, if this had said y equals 4x plus 5 like it did in geometry, it's the same exact thing. You're still plugging in an x and getting back a y. The only difference is, when I was in your shoes, I always thought function notation was a little confusing because I never got the point of the f and the g and the h. They serve no purpose, okay? All you need to know is that x is what you're plugging into the function. That's it. And what you get back will be your y. Plugging in x, plugging in x, plugging in r, plugging in x, plugging in x. And everything you get back is a y value. That's the whole thing. Now, you may be like, well, then what's the point of the f, g, and the h? Because sometimes on your graph, I'm going to ask you to graph 3 different functions right next to each other. I'll be like, graph this one, and this one, all on the same piece of paper. Don't worry, we're not there yet. You don't know how to do that yet. But if I asked you to do that, how would you be able to tell me which one was which? Well, these are just labels. You say, well, this one's f of x, this one's g of x, this one's h. They're just ways to, like, same way you guys have names to differentiate you. F, G, and H are just like the names of those functions. So don't worry about that when you see it on your paper. It doesn't change the problem at all. All right. Evaluating a function, you literally just plug in what's in parentheses. So for number 27, I'm going to plug 6 into this. 4 times 6. 4 times 6 plus 5 equals what? 29. So f of 6 equals 29. Just plug 6 in to the function for 6, or for x. B, you're literally going to plug x plus 1 in for every x in the function. So that's going to be 4 times x plus 1 plus 5. See what I did there? And I'm going to distribute. So that'll be 4x plus 4 plus 5. Thank you. 4x plus 9 would be what that function is evaluated at x plus 1. You won't always get a number. What about part C? That would be 4 times negative x plus 5. And what would that be when you multiplied? Negative 4x plus 5. Easy peasy. Questions on that problem? Let's look at one possibly more complicated. How about number 29? 29. Bless you. Part A, negative 1 squared plus 2 times negative 1 plus 3. What's negative 1 squared? 1 plus negative 2 is negative 1 plus 3 is 2. So g of negative 1 would be 2. Now, here's where we're going to step it up a notch. This would be x plus 5 squared plus 2 times x plus 5 plus 3. Now, today until the last day, an extremely common mistake on every test and every homework is going to be this. A lot of you, and it's just natural to think like this, are going to start this problem and you're going to say x squared plus 25 plus 2x plus 10 plus 3. What's wrong with that? You didn't square this properly. What do you have to do to this? Yes, and what's the word you commonly use for that in algebra? Aluminum foil. You have to foil it. So this is x plus 5 times x plus 5. That's what x plus 5 squared would be. And I'll go ahead and just simplify the rest of it. 2x plus 10 plus 3. We'll make that 2x plus 13. Let me give us some more space, actually. Go away. Let's take this elsewhere and work on it. All right. All right, before this got erased, I believe this said x plus 5 square, plus 2x plus 13. Okay, so foiling x. Let me change colors. That'll be x squared plus 5x plus 5x, which will make it how many x's? 10x plus 25. Then you tack on the stuff at the end. So adding like terms, what would that be? Nice. And that whole thing equals this. G of x plus 5 would be this. Don't forget to FOIL if you're squaring a binomial. And then for part C, you just plug in negative x into this whole thing. Negative x squared plus 2 times negative x. No eating, please. Plus 3. What's negative x squared? Positive x squared. Very good. The negative one just gets squared. Let's see. Won't this be minus 2x? And that would be the last part. You've evaluated part C. Questions? The what? Say what it is? Oh, yeah. Well, the easy way to remember FOIL is to just, the way I do it, just take the x times both of them. So basically just multiply the x by both and the 5 by both. Just multiply everything by everything. It technically stands for first, outer, inner, last. But that's officially what it stands for. Questions from anything you see on the board? Take a look at the rest of these. We've done 27 and 29. Is there a particular portion of one of the others you'd like to see? 31, 33, 35, 37, and which part? I heard 33. Which part? Just all of it? All right. 30. Actually, let me just go down. 33. Part A. So that would be, we're plugging in negative 6 for the R value. So A. That would be the square root of negative 6 plus 6. So what's the square root of 0? 0 plus 3 would just be 3 for part A. Part B would be 10 plus 6. What's the square root of 16? Yes. Excellent. Somebody, this is section 1.2. Flip open to number 33B and see if they give you 2 answers or just 1. I want to say they give you 1. Now here's why. In fact, I'm positive they just give you 1. I mean, you can go ahead and look. But, now, square root is interesting. Square root gives you 2 numbers, which by definition is completely the opposite of what a function is. Remember, the whole thing about a function was you put in 1 number, you get 1 thing back. So, so whenever you see square root in function notation, you just take the positive half of it. You just take the positive. So, there you go. That's why you forget the negative portion. And part C, plug in x minus 6. So that'd be x minus 6 plus 6 plus 3. So minus 6 plus 6 is just going to be the square root of x. Yeah, and there's nothing else you can do with that. Questions on that portion? Only when you're taking square roots or any even roots, you're just going to take the positive part of it. Like that could have been, who was it said plus or minus 4? Very good. Square root of 16 is positive or negative 4. But when you're talking about functions, the whole thing about functions is you put in 1 number, you get just 1 answer. So you're just going to assume the positive. All right. Is there any other problem you'd like to see any portion of? Even if it's just one little piece of one. All of it or just one part? All of it. 37. I think I have room here. Part A. That'd be 6 over the absolute. Yes, ma'am. Okay. So, what is the absolute value of 6? Just 6. So 6 over 6 is 1. Part B. 6 over the absolute value of negative 6. Dude, you're all over it. Negative 6 over positive 6, and what would that be? Negative 1. Part C, that'd be r squared over the absolute value of r squared, which is actually redundant. Just questions. Okay, we already did that. Graph the given functions f and g in the same rectangular coordinate system. Select integers for x starting with negative 2 and ending with 2. Once you have obtained your graph, describe how the graph is related. Okay, here's what you're going to have to do. Let's just jump straight into a hard one. How about 47? 47. Remember I said on the first day you're going to be making XY charts, so like a lot? So, first thing we're going to do is we're going to look at x cubed, and you're going to make an XY chart between negative 2 and 2. So negative 2, negative 1, 0, 1, and 2. And you're going to plug those numbers in. Negative 8, negative 1, 0, 1, and 8. Then you're going to do the same thing with this function, which I'll change colors. G of x equals x cubed plus 2. And you're going to do the same thing with the same x values. Negative 2, negative 1, 0, 1, and 2. Plug those in. Negative 2 is negative 8, plus 2 is negative 6. You're more than welcome to plug these in on your own and check these. Negative 1 cubed is negative 1 plus 2 is 1, 2, 3, and 10 would be your points. Now what they want you to do is graph both of them and describe the difference. Okay, this is all building up to a future lesson we're going to do probably this week. So they want you to graph both. And I'm just going to sketch, but I still have graph paper up here if you want. So negative, I'll do it in colors. Negative 2, negative 8. Well, of course, if you notice, my x's are much bigger than my y, so this might not be perfectly to scale, but just, run with it. Negative 1, negative 1, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 1, 1, and 2, 8. There are my blue ones. Now you're welcome to connect the dots for the graph if you wish. It might help you to visualize it if you do. Now the red ones, negative 2, negative 6, negative 1, positive 1, 0, 2, 1, 3, and 2, 10. Connect those dots. Now how would you in your own words, now granted I'm a horrible, horrible artist, but how would you in your own words describe how the blue one and the red one are related? Wow, that's an interesting way to word it. I've never heard that. They are parallel, but how would you, if I said, how would you get from the blue one to the red one? Just briefly describe. Yeah, I heard somebody say slide. I heard somebody say shift up to. All that would work. That's what I want you to say. You can say it shifts up to, or there may be some of them that shifts left or right or down. So you might say from f of x to g of x, it shifts up to. That's the kind of thing you need to do. What's this graph going to look like? That's essentially y equals 3. What's that going to look like? They're going to be horizontal lines. Because your x's are going to still be negative 2, negative 1, 0, 1, 2, but all your y's are just going to be 3, 3, 3, 3, 3. So it's going to be at 3, at 5. Yeah. Questions? A vertical line isn't a function at all, but a vertical line, see, these are basically y equals 3, y equals 5. A vertical line would be like this equation, x equals 3. That way it's your x that's never changing, and it would be like this. But you won't have one of these because we're talking about functions, and that's not a function. So, questions about what you are going to be asked to do on this page, or is there another one you'd like to see? The exercise, okay, same thing. You're doing the exact same thing. Only thing different is, notice they're giving you specific numbers. A, so that these will be nice and neat square roots when you take them. And B, you can't put a negative into a square root, so that's why they're just giving you positives. That's the only difference between this slide and the last one. Instead of going from -2 to 2, they're giving you numbers and they still want you to describe how they shift. Everything else is the same. In fact, those look like the same problem except for this little part. Oh no, they're radical. Questions? Same exact thing. All right. Now, the vertical line test. When I said, let's go back to slide 1 for a second. These. I said the only thing that matters is what? Who can tell me again? They can't repeat, right? Let's look at like number 1, okay? Actually, we don't even have to look at one of these specific examples. If they just gave you a bunch of random coordinates and said, is this a function? Bless you. The only thing that matters is if you don't have any repeating x coordinates. Now, if you had a repeating x coordinate like this one, wouldn't those all kind of be stacked right on top of each other? Yes, they would. Bless you again. The only thing when it comes to graphing that you have to worry about of whether something is a function or is not a function is if are any of the points directly over top of one another. So that's why they have, and I'm sure several of you, especially all you algebra and trig folks, that's why they have what they call a vertical line test. Could you drag a vertical line through your graph and have it touch the graph in more than one place? This one? No, this one's good. It doesn't touch the graph anywhere more than once. That's a function. What about 59? No, it touches twice here, 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 etc. Not a function. What do you think about this one? Yeah. Breaks don't matter. All that matters is overlapping. Function, function, function. That's the only one that's not. I kind of like this. I've never used this before. Questions? Probably going to puncture my screen now. Are there any questions? Use the graph to find the indicated function value. This is just what it looks like. Remember, what was in the parentheses? Wasn't that our x value? So, at -2, what's my y value at x equals -2? There it is. You guys seem to understand, so maybe I should just stop teaching. That equals -4. We'll just run through these real quick. That would be +4, and at -3, it would be 0. Questions about that? Same thing, except it's called g of x, not f of x. 71 and 73 are the exact same. What does this mean? Yeah, that means y equals 1. Because remember, function notation is the same as y. So it means, where does y equal 1? So instead of looking along this axis, we're going to look along this axis. And at y equals 1, where does that hit my function? At x equals -2. So all of them you're going to give me a y value, except for this one where you're going to give me an x value. Questions? Yikes. Use the graph to determine the function's domain, range, x-intercepts. I know you might be thinking, holy mackerel, we're into the 90s, but it's okay. I do things like every other even sometimes with your homework, so don't freak out. Okay, so let's look at one. How about 85? Actually, let's start with 77. 77, step 1. I surely can. Oh, dang. Hold on, I have to remember what we need. We need domain, range, x-intercepts, and y-intercepts in the piece at the bottom. Okay. Is that better? All right. First thing we need, part A, asks for x-intercepts. You're going to find out I have wonderful handwriting. Where does this thing cross the x-axis? Oh, positive 1. Part B, ask for the y-intercepts. Where does it cross the y-axis? Yeah, that was right. Part C. Oh, I bet it asked for domain and range first, didn't it? Oops. Should have copied and pasted the directions. Let me just scoot these down. Here we go. I believe A actually asked for the domain. Now, domain. Oh, sugar. Did I forget part of the first slide? Did the first slide also ask us for the domain and range? Yes, it did. Give the domain and range of a function. Those other slides would make more sense if I had thought to teach you that. The domain is nothing but the x values. What all x values are listed? The range is the y values. So the domain on number 1 would be 1, 3, and 5. And the range would be 2, 4, and 5. I think they actually have like some kind of squiggly parentheses, but I don't like to use those. Now, even if it's not a function, you can still give me the domain and range, and don't list things more than once. So the domain on number 3, even though it's not a function, would be just 3 and 4. Don't bother giving me the repeats. And the range would be 4 and 5. All the x's and all the y's that are covered. So, are there any questions about how to find those domains and ranges? Back to live action. Okay, our domain and range, you can't just list the coordinates because you have every single coordinate. So the easier way to do it is how far left are we going to go? Forever. There's an arrow. So negative infinity. What? Yes. Well, I'm getting there. It goes all the way to the left, negative infinity. It goes all the way to the right, positive infinity. So yes, you could do one of two things. You could just tell me that it was all real numbers. That's what that cool little R means. Every number. Or you could put it in interval notation and say negative infinity to infinity. Yes. Now the range, how low are we going to go? Negative 4. Does the graph touch negative 4? Yes, it does. That's an important thing. If your domain and range actually stops somewhere, if it touches, you're going to put a bracket like this. That means negative 4 is included. And how high are we going to go? Infinity. You know, you can't touch infinity, so that's always going to have a parenthesis. I think there's other ways to write that. You may have learned in Algebra 2. If you have a different way of writing domains and ranges, by all means do that. That's just how I write it. So, questions about how I got those? We'll look at another one like that in a second. Okay. Part E just basically asks you to figure these out. That's what E is. So, f of negative 2 is what y value? Negative 3. And what is f of positive 2? Looks like I can't really tell. I'd accept 4 or 5. I think it's actually 5, but that's fine. You'll be able to see your books a little clearer. So there you go. Questions about anything that we did that's on the board? Yes, sir. Yes, that is perfectly fine. Was there a question over here? Well, the domain is what all x values are we going to have? Like, let me come back to this one just a second. Like, for instance, look at number, look at 81. How far left does 81 go? I'll make it bigger in just a second. 0. How far right does it go? See, so that one would have a domain of 0 to 5. But the one we were working on, because it has arrows, implying that it keeps going, that's why it was all real numbers. Okay. Now, let's actually look at, just kidding, that's not your assignment. Let's actually look at 81 and answer that one, and then we can come back and answer any other ones you guys want to see. 81. All right, part A. How far left does it go? 0 to 5. Now, which one has a bracket and which one has a parentheses? That's right. The open dot means it is not included. It is an empty space. So 5 is not included. The range, how low does it go? And how high does it go? With a move-in. And x-intercepts, where's across the x-axis? Y-intercepts, -1, it does touch there. And part E, answer this piece. What is f of 3? Questions? Sure thing. See how this is a filled in spot? That means that point is included. So you put these in here to show that 0 and -0 and the x and -1 for the y, those are actually on my function. But this is empty, meaning this point doesn't actually exist, it's just where it stops. So that's why they get parentheses. The reason that's important is because if I actually asked you, if I said, what is f of 0, you could concretely tell me that that's -1. But if I asked you for f of 5, that does not exist. That point is not on our function because it's empty. Yeah. Okay. No, just kidding. Let's get attendance. Look at the board. If is there a particular problem somebody would like to see work? Good question. 91. '91 is actually just like the first problems we did in that it's just 5 different coordinates. So, however, the domain and range, you're not just going to say -5 to 3 because that would imply that all this was in there too, and it's not. So when it gives you coordinates, you're just going to have to list those. So what x values does this thing cover? Very good. That's the domain. What's the range? Just 2. All the y values are the same. What is the x-intercept? None. What is the y-intercept? Now part E, what is f of -5? 2. What is f of 3? So that would be 4 because it says this plus this. That was a good question. That was definitely the oddball. Questions? Then we are finished. Every other even, which basically means like you count by 4s.